Good morning, everybody. Today's lesson is actually on electronegativity and ionization. We're going to describe the periodicity of electronegativity, which is a special property, and let's dig into it. So this is on page, let me just double check, page 20, I believe, 21 in our note packet. And yes, we're back in our note packet. And the best way to describe what electronegativity is the desire to gain an electron. So it's the desire, even though it's sort of like giving atoms the properties of humans, they don't really have desire, but it's that force that pulls electrons. So how badly does every element want to gain an electron is a measure of electronegativity. You could describe it as its greediness of an atom for an electron, just like the Grinch. Okay? The Grinch. Why? Mess it up a little. The Grinch. Okay. And so the first thing we want to recognize is that nonmetals, those that are on the, let me just talk about those, towards the right on the periodic table, those will have high electronegativity. And so when we think about them, we want to think nonmetals. Gain electrons to achieve a full octet and therefore have high electronegativity. And what we've also found is electronegativity is one of those properties that periodically change. Because every time we reset and go all the way to the end of the periodic table and reset to the beginning, we find that metals start the process all over again because they like to lose electrons to achieve the same idea, the same octet, and therefore they have low electronegativity. It's good to write this out. Sometimes I abbreviate things, but that's only after we got the spelling down. So the only way we get spelling down is by practicing. So across the periodic table, we'll see that it ranges from 0.0 to 4.0. To better show you this, I want to show you a chart from a website that I thought was a little bit more instructive. And you'll see it's a fairly good chart. We have our high that we just talked about, a 4.0, and our low 1.0 or below. And then we have all of these elements color-coded. So you'll see these purple ones are the corner of the periodic table outside without the noble gases. Noble gases don't have any. Why? Because they have a full octet. So we got our highest electronegativity. And then over here you'll see the pink ones, I'm going to say salmon or pink, and they have our lowest electronegativity. So as you move across and to the right, we have increasing electronegativity. So we'd expect acetine to have a higher electronegativity than potassium. We'd also expect lithium to have a little bit higher than francium, and it does. You'll see that pattern. That electronegativity goes down a group. Nitrogen is 3, bismuth is 1.9, and goes up across. So from left to right, electronegativity goes up, and then going down, electronegativity goes down more and more. Okay, hope that helps. I think it's a handy way to look at it. I'll give you some other data, but let's move on. Hey, good morning. The most electronegative element in the periodic table is going to be, francium. And the least electronegative element, see it, Andrew? The element is going to be fluorine. Oh, okay, sorry guys, I got distracted there for a second. I should have been more careful. The most electronegative element is going to be on the far right, which of course is fluorine. And the least electronegative element is going to be francium on the bottom left. Okay, its electronegativity numbers there are incredibly low for like francium. It's below 1, it's 0.7, but it's hard to measure. 0.7. So going across a period, like I said, so as we go across a period, so going this way, electronegativity increases. The reason is because we have an increased nuclear charge, which increases the desire for those electrons. The number of energy levels increases the amount of shielding. And so if the shielding does not increase, and then the electronegativity, it does increase. Because there's nothing to stop that pull for the electron to be pulled towards the center. So as we look across a period from sodium to chlorine, how many shells does it have? Well, let's take a look at a periodic table. You'll notice sodium is right here, chlorine is right here. They're all in period 3, so they all have the same number of electron shells. If you have the same, electrons are just living the same distance away from the nucleus, the more protons you add to the nucleus, the more they'll pull into that electron and hold it tightly. Okay, so if you go down a group, electronegativity decreases. The reasons is the number of shielding levels, which I'll show below. The number of shielding levels increases. And you can sort of see that in the diagram below. What that means is if you're an electron sitting out here in hydrogen or lithium, that valence electron there, there's not much distance or objects between you and the nucleus. It pulls in tight. But for an electron that I'm going to highlight in yellow here, this valence electron, you'll see there's 2 levels of shielding between you and the nucleus, so the nucleus doesn't have that strong of pull for you. All right, and that's that concept. Now, what's another way to measure electronegativity? It's how much energy electrons it takes to remove an electron. So the amount of energy needed to remove the most loosely bound electron from an atom to create an ion. Values for each element are listed in table S. So let's take a look at table S. And I might need to zoom in here. And I'll just do one little zoom. And we'll move in here and go to our table S. And you'll look on the top and you'll see electronegativity right here. And you'll see how it starts at 2, goes to 2. That doesn't help. But look at 1 to 2. Look at 2.6 to 4, 0.9 to 2.2. What you'll see is a periodic pattern reset by every group. So let me just move that to the side. And so if atoms are stingy, they hold on tight to their electrons, then they act like Scrooge, which is a character from Disney as well as an actual movie and book. I recommend it. So if you have an atom and you add energy to it, and then that atom becomes an ion, so it takes on a charge, and in this case a positive charge because it loses an electron, that amount of energy is what we call the ionization energy. Going across the period, I think I showed it to you, the amount of ionization energy increases. The reasons are is because increased nuclear charge, and the number of shielding levels across the period stay the same. So the number of energy levels also known as shielding, the energy levels cause the shielding, doesn't increase across the period. It's all the same period. It's all the same energy level. All right. But going down a group, I think you recognize the ionization energy decreases because you have more shielding. The reason is energy levels increase every move down a group. So the number of energy levels decreases. Oh, my bad. Decreases, increases. The number of energy levels increases, just ionization energy decreases because, again, the explanation in the short response will be shielding increases. That's the concept I want you to get, not just for the test, but understanding life in general. All right, this is our last page. Reactivity. That's an interesting thing because people can be reactive, atoms can be reactive. It means something happens in the outside world and an organism or material react to it. So it's the ability or tendency of an element to go through a chemical change or react with another element. For examples, metals are losers. It's sort of a harsh thing to say, but what I mean by that is that they lose electrons, and nonmetals are bullies. And that's also a mean way to say it. But nonmetals are bullies because they take everybody else's electrons. All right, let me pause. Okay, so again, metals are losers, nonmetals are bullies. Don't take it the negativity, sorry. It's just a way for you to understand. You can't really compare metals to nonmetals. Okay, so how about metals? Recall that the most reactive element is francium. It's so reactive we can't even isolate and look at it. Going across a period, reactivity decreases. So every step of the way across, like the period, things get less and less reactive. The reasons, and you remember that because, let me just pull open my periodic table, is we did the group 1 video where we showed all of these alkali metals, and how they reacted to water, of all things, which is not a very reactive substance. So the reasons they're so reactive is, for metals, are they have increasing nuclear charge, which means they hold on to their increasing nuclear charge. They hold on to their electrons more. And then their shielding stays the same. So shielding does not increase. I hope you guys are getting the pattern of how we're increasing. So it does not increase. Going down the group, reactivity does increase. The reasons are there's increased shielding, so the electrons are held on less tightly. So it's easier to lose electrons. All right, and we've seen this already. So nonmetals, just remember that those are on the top right. The most reactive nonmetal is fluorine. It reacts with almost everything. If you've ever seen Breaking Bad, you'll notice that hydrofluoric acid is mentioned right in there. Very reactive. Going across a period, reactivity increases in general. And then you get to the noble gases and something happens. Noble gases are non-reactive, so they're completely unreactive. And the reasons for this, well, not for the noble gases are unreactive because of the octet. The reasons for the reactivity decreasing is because you have increased nuclear charge. Nuclear charge. And shielding does not increase. Going down a group, reactivity decreases.
The lights aren't working.
And it's because you have increased shielding. That was Reagan, by the way. Thanks for letting us know. So increased shielding in nuclear electrons. She'll be forever captured in this video. And that concludes this video. Thank you guys. We actually concluded the packet with this video as well. And these are all the things you should be able to know. And your homework for today is going to be, let me zip to it, know packet 2022, which we just did, and practice packet 21 to 22. Have a great day.